Okay, so now we move on to X11 and getting that installed. There's a few bulk compiles here, such as this first one, XCB Utils. The idea is, again, that we've already seen, is that we've got a steering list here that it fetches these, and then we've got an as root script which will get us root access to do the installation, and it all automates it. So as I say, I've already downloaded everything, but you'd need to copy and paste all of that, all of these commands, to go and fetch them and then start building as I'm about to. And it creates this XCB utils directory, utils, and there's the files already downloaded. You won't get the index.html, it's just something that's come down when I've mirrored the files off my server. So I'm going to put this function in. It'll become part of the current running shell, so it'll be available as root, and you can put a command in and it will run it as the root. And we'll start a new shell off that will exit on the first error that occurs, and we can compile these packages with these commands and wait for them to build. And it won't be too long, they're quite rapid. And you can see that's finished now. So if I just type exit, it should return, and that's XCB utils completed. So X bitmaps is built on its own. So configure and install. And that's done. Xorg application. So again, this is a bulk load of packages to compile. So same thing as before, copy and paste that list, and you'll end up with that file there like that, and then run these commands to make a directory called app, and it will download the files like that. Again, ignoring the index.html, you won't get that. Probably don't need to do this, but I'll copy it anyway in case it's slightly different to the one before, rather than risk any errors. Run a new shell that'll exit on an error and build all of those packages. Okay, that's finished. Now let's exit that. And it says unless you install the optional dependencies, remove an undocumented script. So we didn't put the optional dependencies in, which are we've got that one. There aren't any optional dependencies. Yeah, we've installed all of these, so that doesn't really make sense. It says X keystones provided by the XR&R package. I'm not sure if we install that anyway. Is it here? Oh yes, it is. Has been installed. Okay, so we could provided by the. Oh, I see. So it's been installed by the XR&R, and apparently it's broken. So, right, yeah, let's remove it then. Reported to be broken. That sounds like gossip. If there's no firm evidence, but remove it anyway. If it is needed, not sure what it does, but if it is needed, obviously you can just build XR&R using these instructions here. So that's the apps. Now we move on to cursor themes. And we just configure and make to build that. And install. And that's done. And move on to Xorg fonts. Sorry, right, yeah, this is another one that's built in bulk. So again, just copy and paste this to create the steering file and then run these commands to download them. Got another S root, which again looks the same, but I'll copy and paste it to ensure it's the correct one in case there are subtle differences with what we've been doing previously. Enter a new shell that will exit on an error and then run those commands to compile these packages. And that's done. Exit that environment, and that's the fonts finished. X keyboard config next. So build with these commands. And install. And that's done. And move on to libepoxy. So build. Run some tests. Well, most of them were skipped. Maybe because we're not inside graphical environment, because they look like they're GL related, all of them. So we'll just go straight through it and install. And that's that one done. Move on to Xorg server now. So some information on additional downloads and optional packages, etc. Again, we've got some kernel configuration settings, so we'll just quickly check them, make sure they're set. So DRM we've already checked. VMware not interested in, in fact not interested in any of these. They're for virtual boxes, virtual machines rather. So I'm not really bothered about them, so I'm not going to check anything else. I've already checked that DRM exists. If the kernel does not provide a DRM driver for your GPU or most x86 systems, there's a simple frame buffer DRM driver running on Visa or UEFI frame buffer that can be used as a fallback. So you can enable the following options in the kernel configuration if you don't have a dedicated DRM driver for your GPU, or if you want to keep a simple frame buffer driver as a fallback in case the dedicated driver fails. So I'm not sure if I've actually set that up or not. Let's take a look. If I haven't, I wasn't aware that I needed it. Right, I have set it, yes. And I've probably set this as well then. Okay, yes, I have got a fallback then. And it says there to allow the kernel to print debug messages early on in the boot. They've got to be built into the kernel, these two options. DRM and simple DRM. If you want to use a simple frame buffer driver on a system booted via BIOS instead of UEFI, add the following line before the first menu entry block in the boot grub to initialize the Visa frame buffer. Okay, that's interesting. I might add that in because I do remember when I was installing the booting using the NVIDIA driver, it seemed to come up with the wrong resolution. Although that would suggest that it wouldn't work because it's not Visa. Although maybe it's what it uses. I'll try that. VI. So it says to put it. Oh, there it is. There, right. So I'll paste a new one there and set it. So that may be why it did set it to a funny size. I think I've got a HD size screen on that laptop. I presume I have. Right. Yeah, as I say, I think for the Intel driver, if I do find I need that, I'll have to do this to go back. I think we'll find out anyway. I'm not going to worry about that now. So xorg xvf server. Okay, so we've got a patch to put in first, and then we can configure and build with these commands. Okay, it's done. We can run some tests. So it says you need to run ldconfig first to reload the shared libraries, the index to them, and now we can run the tests. And they've all passed. One's been skipped, not sure what that is. So we can now install. And so if you're not using eLogin D, you need to add the user to the video group, which we are using, so we can skip that. And move on to X11. So compile it with these instructions. Okay, and we can install it with these instructions. And that's complete. We don't need to do this because obviously we have just installed that. And move on to mtdev. Build that. And install it. And that's complete. Xorg input drivers. So we need to select which of these we need. I'd recommend installing the first 4 and the other 2 optional. So because it's a laptop, I'll be installing the Synaptics driver, the Wacom driver, well, a tablet to use maybe for graphical needs. I don't know if there are any gaming devices that might use the same interface. That is a possibility, so you might want to install that as well in case you have some device, maybe a trackball or something, I don't know, or some other device that may use that emulation. Once again, we've got some kernel settings that are worth checking. So if we check the input, there's quite a few there, but fdev should be there. There it is there, set, so that's good. And we've got the config input obviously set to yes as well. So let's extract libfdev. So this is kind of like the system driver, and then there'll be a driver after this for Xorg, which will probably use this driver, I'd imagine. So the tests need a graphical session, so I'm not going to bother with that. I'll just go straight for an install, and that's done. So now we've got the Xorg driver. As you can see, it requires the kind of system driver, I'd call it. So extract the package, and build it. And install, and that's complete. Now we've got lib input. Generally I tend to install this, not the evdev, but it's probably a good idea to install both. Things are in here, lib input. Install that, and I didn't set the documentation to true because it didn't say anything about that, but I guess I could go back and rebuild that. I'm not sure if it's API documentation actually, but it doesn't say that, so I'm not too worried about that. So that's lib input. So again, now we've got the Xorg driver, which uses that system driver. So input lib input. So build that, and there is a test here which we can run now, and that's all passed. Install, and that's done. And like I say, these last two are probably optional, but I'll do the Synaptics purely because of the reason that I'm on a laptop. X86 input Synaptics. Okay, and install that. I won't bother with the Wacom driver because I know I don't need that, but you can see it's fairly straightforward. A few settings in the kernel again, but straightforward installation. And move on to Xinit. Build that. No test suite, so I'm going to install and run ldconfig. So if starting Xorg from the command line, the default instructions above start Xorg on the current virtual terminal. It may be convenient to see Xorg and associated application messages on the current virtual terminal, normally TTY1, and start the graphical environment on the first available unused virtual terminal, normally TTY7. To do this, set the SUID bit on Xorg application as a root user. So at this point you can start commands with this command here, and should be able to toggle between to automatically start Xorg on the first available virtual terminal. Modify the start X script as follows. After this, the virtual terminal does not to be specified on the start X command line. Right, I've just realised both of those need to be root. So I haven't got any packages obviously at the moment to show that the Xorg will start. So what I'm going to do is to go to GLFS and install TWM, which is a very basic windowing manager, an Xterm, Xclock as well, which allow for a pretty basic desktop, but allow you to actually use a desktop. And it's also a good way of testing the graphical environment to make sure that the graphical part of it is working correctly, without having to individually start graphical commands. And as I say, I haven't really got anything, certainly nothing I can think of to test this, and there's nothing suggested here either. So I'll go to GLFS, find TWM. There it is there. I'll get this in a new tab. And this has several requirements. No, it doesn't. Right, X terms there. X clock. Right, okay. Right, TWM. So let's tidy up X init and extract TWM. Oh, I'll put all these into a subdirectory, that's right, to keep them separate from the main GLFS build, because they're not officially part of it, they don't appear in the book. So extract TWM and build it with these instructions. And then install that. Then move on to Xterm, and that needs Lewitt and some fonts. So let's put the fonts in first. So Deja Vu fonts is what we need, and the example is given up here. If you click on this list, it'll take you to the SourceForge where you can download the fonts. It's a bit annoying, this website. Basically, if you click into, in fact, you can download it just by clicking here, and that will allow you to download, or you can go into the folder here for the latest version and maybe select another format. But the one you want is that one there. It says Deja Fonts TTF. Or you might want the zip file, but that one there is the one you want. See, the one with the most downloads is the one that you'll want. And then when you've got them, extract them. So extract them like that. They'll extract into the directory, change into it, and then as the root user, run those commands. So I'll become the root, paste those commands in, and although you get some kind of like errors there, not cleaning non-existent cache directory, as long as you see that line there, they've been installed correctly, And in fact, you could check that yourself by running a listing on that directory. You can see all the fonts that have been installed there. So tidy that up. That's the fonts done. We move back to Lewitt, which needs to be installed. So extract that and build it. And install it. We can go back to building Xterm. Okay, now we can install it. That's done. There's some configuration here. So we can put that in to create some basic configuration. And that's Xterm done. And one final thing you can do is to put a clock into the system as well. And install that. So that should be sufficient to get a graphical front end going. In theory, all I need to do now is to log in on the laptop and type StartX, and I should get a desktop coming up. Obviously, if I run it here, nothing's going to happen. In fact, it has actually just spawned the desktop on the screen. So it's done that using the Intel driver, because like I say, I haven't rebooted and forced the NVIDIA driver. So what I'll do now is to stop this video, and I'll just come out of it there and reboot and keep my fingers crossed that the HDMI port actually works with the NVIDIA driver, and we'll see it all working. Okay, well, the NVIDIA didn't work on the HDMI port again, and I did look at trying to configure it, but it's something I know very little about, and there seem to be so many ways of trying to get it to work, and what I did try didn't work. Rather than wasting time on that, which is not really the focus of this series of videos, I thought what I'd do is just carry on doing the rest of it with the Intel, which does work still. Interestingly, the NVIDIA driver did come up at the correct resolution with that modification I'd made to the grub boot file, so that was interesting. It shows that the NVIDIA is using the Visa standard and recognises that setting as set in the config that grub must obviously use to configure the video mode, so that was good. So it would mean that using the native built-in screen, using the NVIDIA card would be an option, but obviously as it stands with the HDMI port trying to grab the screen, it doesn't work. without a lot of further investigation. As I say, I'm not really very knowledgeable about that sort of thing. I've never had to set it up, so I'd have to spend some time researching that to get that enabled if I needed to.